Hi guys, today we are going to read about concepts and ordinary differential equations. Under this, we may define some terms. The first term, I want to define what are differential equations. Second, we talk about what is ordinary differential equations. And then we have third one, partial differential equations. So first thing, we find out what are these differential equations. We have ordinary differential equation. Simply, differential equations, these are equations involving derivatives. Talking about derivatives can be one or many unknowns. These are unknowns. They involve what we call variables. Variables are the ones that can be either one or more. So in this case, when we are told to define what are ordinary differential equations, these are simply derivatives involving only one variable. When a differential equation is involving only one variable, we say that type of equation is an ordinary differential equation. Then we have what we call partial differential equation. In this case, when they involve many variables, or let's say more, in this case, we are talking about variables. The equation is said to be partial differential equation. Then, simply, you can have an example of an equation. We have, let's say, dy over dx equals 2x plus y. So this differential equation involving y. Then you have a variable x. Then we have these equations can only either be linear, ordinary, differential equation, or they can be non-linear, ordinary, differential equation. In this case, we are going to define what are these linear, ordinary, differential equations. Simply, these are equations which can be written in the form A, you have the naught, x, then you have y1, and then plus a1, x, y, then you have a, n, x, the form. So when an equation is not written in this form, it is said to be a non-linear ordinary differential equation, where f of x, this one is equal to f of x. F of x and the coefficients of, when I'm talking about the coefficient of, I'm talking about the coefficient of a naught of x, then you have a1 of x, then you have a of x, then you have a n of x. These coefficients, these are just representing the variables in x. And the value of a naught is not equal to 0. Not that different. Then we have, when you are calculating all this, we reach at two types of solutions. In this case, we have the first one as a general solution, and then the second, we have particular solution. In this case, when you are told to calculate a general solution, this is just a solution to a differential equation involving variables of one or many, or let's say more variables. To talk about an So in this case, they are finding the arbitrary constant in the form of a constant C. Then when we are told to find particular solution, this is just an additional information. This is an additional information from the general solution. In this case, the additional information is to calculate the arbitrary constant. In other words, the information is to find what is all about the constant. That constant what we call the arbitrary constant. So to differentiate the two, let's have an example, a quick example, to know what are these general solution and particular solution. Let's put out an example. We are told find the general solution of an equation. Let's say x dy over dx equals to 2 minus 4x cubed. So in this case, the first thing, you rearrange the equation. In rearranging, what I mean, you write dy over dx. First thing, you write 2 minus 4x cubed, and then over x. The x, you have divided here by x, then here by x, so that this x will move itself this side. After this, you have dy equals to 2 minus 4x cubed over x, the whole of this dx. Then you will integrate. Now, when you integrate dy, you get y. This one we write, you integrate, this one will be 2 over x. Then this one will be minus of 4x cubed over x. So in this case, you have x and x cubed. When we divide, we will get x squared instead of x cubed. Then we are integrating separately. Then the x. So we have y equals to, this one will have 2, the natural logarithm ln of x, and then minus, this one will be 4x cubed, then over 3, then plus c, the constant. So our general solution will be y equals to 2, then ln of x, and then minus 4 over 3 x cubed plus c. This is our general solution. This is our first example. When you consider the second example, let's use our second example as you have been given to find the particular solution. Let's say you have an example of, let's say 5 dy over dx plus 2x equals to 3. Then you are given when x is 2 and y is 7 over 5, this case. So the first thing, follow the same procedure, find the general solution first and then the particular solution. So in this case, you have dy over dx equals to, take this on the other side, say minus 2x, then plus 3, then divide by 5. You will move this 5 to the other side, also 2x to the other side. Thereby, we will have dy equals to minus of 2x plus 3 over 5 dx. The function is x, the other side. Second thing, you write the integral part of dy equals to minus of 2x over 5, then plus 3 over 5 of this dx. Integrating. So integrate this, get y equals to, this one will get minus of 2 over 5, then this one will be x squared, then over 2, and then plus, this one is 3x, 3 over 5, then x, and then you add a constant c. Then we write y equals to, so these two will cancel, so we now have minus x square over 5, then plus 3 over 5x plus c. So this is our general solution. But we have been told to find a particular solution. So there are some additional information which are given. In this case we have where x is equals to 2 and y equals to 7 or 5. So we just log in and then continue to find the value of c, then we substitute to get the particular solution. So this case will be 7 over 2, 7 over 5 mean, equals to the value of x here, in this case at the beginning was 2, so it's minus of 2, here squaring, it's a negative of x squared, then of 5, and then plus 3 over 5, then x is 2, then plus c. So we'll get 7 over 5 equals to negative of 4 over 5 plus 6 over 5 plus c. So this case will be 7 over 5 equals to, the LCM of this all will be 5. Then you have minus of 4 plus 6, then plus c. So you have 7 over 5 equals to 2 positive over 5, then plus c. So our c will be 7 over 5 minus 2 over 5. So our c will be the LCM of this is 5, then 7 minus 2. So our c will be 5 over 5, which is 1. So to write the particular solution, our general solution was y equals to minus of x square plus 5 over 5 plus 3 over 5 x, then plus c. So our general, this is our general solution. Our particular solution will be y equals to, we have minus of x square over 5 plus 3 over 5x, then plus the value of c is 1. This is how we differentiate the two, general solution and particular solution. The general solution having a c, and this case, particular solution, the additional information aids us in getting the value of c. So this is our particular solution. Thank you for watching. Thank you.